Let's talk about Chapter 7 from the Gaddis book, which covers input validation. Input validation is very simply protecting your program against bad data. So if your program is looking for data, say it's data supposed to represent a mileage range or a grade or a phone number or something like that, you need to make sure that the data that's being entered is matching what you expect it to be in format and data type and so forth. So um, in this course so far, we have not been doing much data validation. We've done some for making sure that things are positive, but we haven't protected ourselves against invalid numeric data and things like that. So we're going to cover some of that. So here's an example um, of data coming in and out. Example here's the user entered 400 hours as the number of hours worked, which is probably not that's probably beyond what you would expect for the number of hours worked in a week. That's an example of where you might get bad data or data that doesn't make sense in the context of your program. We typically do input validation just using if statements. We just check to see if the number is positive, if it's between a range, if it's just makes sense within the context of what we have. We can use a while loop to continue to force the user to enter data and just stay in the while loop until they comply with the requirements that we've given them. We typically use a function to do input validation. So, for example, if we're looking for a grade to be entered, the grade needs to be between 0 and 100, and it needs to be an integer. So we would write a function called maybe get integer in range, and we would just have that loop until the user enters a valid integer in the range that we're asking for. It's important also to make sure that if we're giving an error, if the user enters something in error, that we tell them what was wrong. So we need to tell the user what kind of data we want and what the parameters are. It should be obvious to the user. And then if they enter something that's incorrect, we need to tell them why it was incorrect and how to correct the error. So we need to be guiding our user to what we want, not making them guess. We also need to consider if the user enters the wrong type of data. So if we're looking for numeric value, an integer, or a double value, we want to make sure that if the user enters something that is not valid numeric, that the program doesn't halt or cause a runtime error. This all applies not only to data that's being collected from the user, but also for reading data from a file, or maybe we're reading data from a database, or wherever we're getting data, we need to make sure that we have trust in the source of the data, that it's being validated and it's matching the anticipated entries. Here's some more examples: state abbreviations, zip codes, hourly wages, things like that. It's unlikely that anybody makes $500 an hour unless you're a lawyer. You're not going to work 600 hours in a week, things like that. Dates should be checked. There is no February 30th, for example. Maybe you want to make sure that the date being entered is prior to today, or maybe it's a birth date. You want to make sure that it's not in the future, things like that. So these are all types of input validations that we would want. In Java, we use a try catch and exceptions to check for non-numeric data coming in for when we want numeric data to be entered. This is not covered in the Gaddis book, so I'm including some examples here from a different textbook. You can look up try catch on the internet anywhere you want. So the way that a invalid numeric input works in Java is you'll get something called an exception. So an exception is an error that's being thrown. You've probably seen these when you run your code. If you have a runtime error, you get something that looks like this. This is what we call the call stack. This is an exception and the call stack of what's being run. So in this case, the exception was thrown, number format exception for the input. In this case, the input was $100. And this says this is not valid. It's trying to do a parse double, and it can't parse a double because the $ is not a valid numeric, digit, and so it's not parsable into a double. So it's throwing an error. So this is what we call an exception. We talk about exceptions. We talk about them being thrown. So the program will throw an exception. if something goes wrong. So we can try to capture those to protect ourselves from bad input. So in both cases of using integer and double, when we're using the parseInt and parseDouble, we're going to get this exception, a number format exception. We'll also see exceptions, that will be thrown if you maybe you're trying to do formats and you're using the incorrect format strings, or you'll get other exceptions if you just have bad input or make mistakes in your code. But these are the two that we're going to focus on. Well, the one exception from two built-in methods, parseInt and parseDouble, the number format exception. So in order to catch those, we use a try catch block. So in this case, this looks just like it's a block, just similar to an if or a while. We have a try block, and inside the block, the curly braces, we have statements, and then we have a catch, and then we're telling it what exception we're catching. And then with our statements that says that will be executed if there's an error. So in this case, we're going to try what's in this block. If this error occurs, we're going to catch it and we're going to execute this statement. If no error occurs, then the catch block is never executed and these statements do not apply. Here's an example in real time. In this case, we are attempting to capture double entry from the user, from the command line. So we do a parseDouble. We take the scanner, do with the next line. We then, if this works, then we say, congratulations, you entered a valid number. If it doesn't work, we catch the number format exception. Notice this is a catch. This looks like a parameter of type number format exception. That's where we're catching, and then we name that parameter E. So in this case, we'll actually get a variable in our catch block named E that will have the contents of the exception in it. An exception is an object in Java. You can look at the contents of it. You can see the call stack. All of those things go on with the error. So in this case, we have caught an invalid error. So if I come in and I type something that's not parsable into a double value, then this catch block will execute and we'll get this message, at which point I would typically have a while loop that I would go back around until the user enters what they want. Here's the same code embedded in the while loop. So in this case, we have a method get double. We're going to use a while loop while true. We're going to just continue until they enter the data we want, and then once they do, we return the value when the while loop ends. We can add other things in here like range checks, common sense checks. Does the number make sense in what we have? So, but this is the most basic. Just get a valid double. We typically would wrap this into another method called maybe get double in range, where we would add. In that method, we would add the range check. We would use this get double method to get the double value, but then in our get double in range, we would add additional checks to check for the range, or maybe to check, is it an integer that's 5 digits? If we want a zip code, is it all numeric? Are there any, does it have the right number of characters in it? Things like that. So here's the range check that we would add. In this case, we're using get double in range, and we've had two additional parameters, min and max. We're calling our get double method. We know that that this method will return a valid double, so we don't have to do the try catch block here. We just add the range checks to the data that's coming in. Okay, notice that we have the same method here, the same function, the same name of the function, but it has two different parameter strings. This is called overloading in Java, and so you can create multiple functions and multiple methods in your program with the same name, as long as the parameters signatures are different. And so in this case, the parameter signature here is a scanner and a string. For this one, the parameter signature is a scanner, a string, and 2 integers. So because those signatures are different, they have different parameter types. You can use the same name of the function just with different parameter types. What makes the function unique is the name plus the signature of the parameters. And we'll do an example here in another video.